All right, so a vat of milk has spilled on a tile floor. The milk flow can be expressed with the function R of t equals 4t, where t represents time in minutes and R represents how far the milk is spreading. So the spilled milk is creating a circular pattern on the tile. The area can be expressed with this formula. And then it says, which of the following shows the area of the spilled milk as a function of time? So that's why we gave you guys the word problem on the exit ticket for 6-5. So this was from the 6-5 lesson. And it's talking about those like functions within a function. All right, so it gives you two different functions. One is R of t, the other one is A of R. So what do they have in common? What letter? They both have R's. So kind of like the one that we did in the exit ticket where they had something in common, these have an R in common. And if you look, this would be the innermost one, the R of t, because then it's being placed inside of here, if that makes sense. So the outside brackets would be the A, and whatever we get from the R function will be placed into the A. So we can already eliminate C and C. Am I making sense so far? All right, so then because R is the innermost, we take what R equals, which is 4t, and we're plugging it into the A function for the R. So anywhere there's an R, replace it with 4t. We get pi parentheses 4t squared, which matches this one the most. All right, or actually, what did it say the right answer was? Let me think. Is that it was B? Okay, so I'm thinking what they did was they distributed the exponents. So that even got me a little bit. Not sure if I should make this one extra credit or not. I'll see like how many people missed it. But it looks like they applied the power rule, which means that this gets distributed to both things inside. So what's 4 squared? And then t to the power of 2, bring down the pi, and then they're just rearranging it. All right, because normally the numbers will be your coefficients. So they just reorder it. Does that make sense? Okay, that one was a little tricky. I'll look and see if more than like 70% of the class missed this one, then I'll probably make this one extra credit. Score you out of 19 instead of 20. All right, so questions on this one? Questions on a different one? Yes? All right, so that's the G one. So is this one number 13 on all your guys' screens too? Yeah. Okay. All right, so at least that worked out. All right, so consider the function f of x equals 3x and g of x equals negative 2x minus 5. What's the value of f of g of negative 4? All right, so a lot of people missed this one, but I mean, we did go over it, so I think it's just one of those things that are difficult for kids, because it's read f of g. So is it my fog or is it my fog? Fog. All right, so is it f going into g or g going into f? So what I'll usually do, since my innermost function is g of negative 4, so they give me a number this time, under my little picture over here, I'll put g of negative 4 where I plug it into that g function. So then it becomes negative 2 times negative 4 minus 5. What's negative 2 times negative 4? Positive 8, and then minus 5 would be 3. So g of negative 4 is 3. Now that I know what g of negative 4 equals, I take what it equals, which is 3. I'm going to plug it into the f of x function for the x. Sorry, I didn't mean to draw all the way up there, but into the f of x function. So now it's going to be f of 3 equals 3 times 3 squared, and go in your order of operation. What comes first, multiplying or exponent? So it should be 3 times whatever 3 squared is. What's 3 squared? And 3 times 9 is 27. All right, so your functions within a function. You will see another one like this on your retake. And it's open response, just like this one. All right, questions on this one? Questions on any other ones? Number 20. Okay, so the division problem. Again, you'll have something just like this on your retake tomorrow, but it'll be open response. So for this one, you can do 2 things, whatever is easier for you. If it's easier for you to break it into smaller fractions, then do that. So make sure you keep the sign that's in front of each term. And we're dividing all of the terms in the numerator by the denominator. So that's one way you can do it. The other way that I showed you was like you could take a highlighter, maybe just draw circles with your pencil, and make sure you divide each numerator by the denominator. All right, but I'll show you with the fractions over here. So the coefficients you treat like normal. What is 6 over 6? 1, it cancels out. What's x cubed divided by x? X squared. So you use that quotient rule for the exponents. So I would write this one down on my yellow paper. So x to the a over x to the b. What do I do with the exponents? Subtract them according to this rule. So if you need all the exponents written on that paper, I would write them on my paper, at least tonight. So x cubed over x to the first, subtract them, 3 minus 2 is 1. And then we're on to the next term. What is negative 18 divided by 6? Negative 3 is correct. X squared divided by x. Good. And on to the last one. So I have a negative 12, because you always keep the sign that's in front of the term. Negative 12 divided by 6. What do I get? Negative 2, and then x divided by x. X to the 0, which equals 1. Anything to the 0 power equals 1, which I'm not going to put negative 2 times 1, right? So what's negative 2 times 1? Negative 2. So in other words, it cancels out. When you have the same thing on the top and the bottom of a fraction, like same exact thing, x to the first over x to the first, it cancels out. It's no longer there. So that is why A was the correct answer, right? Get that one right. Okay. Good. Any others from the test? Yes? 16. All right. So this one, easily one of the most missed ones on the test and on the retake too, I can imagine. Because people see this and they automatically want to apply the power rule. Do not do that. All right, whenever it's in this format, I'm saying that I'm taking this set of parentheses and multiplying it by itself, because that's what exponents tell you to do. So the first step is to do what? No. Think back to when we did the binomial times the binomial. Good. So first step is we need to expand it. So if it looks like this, expanding it means it looks like this now. And same thing where if it was a plus in the middle, then it would be plus. Does that make sense? So this becomes this. So now for this specific problem, it's x minus 3 times x minus 3. Make sense? All right, now from there, what do we do? So we double distribute or FOIL, whichever is your preference. I think this class you guys said you like to double distribute, which is the same thing as FOILing. What's x times x? X times -3. And then what do I distribute next? Good, the -3. So -3 times x is, and -3 times -3, +9. That's good. So we're here, what do we do after FOILing / double distributing? Combine like terms. So what are my like terms? And when I combine them, I get, I'm sure some of you thought they canceled out. Just look at your signs more closely. All right, you can even put it in your calculator. There's nothing wrong with that. -3 minus 3 is -6. So you combine like terms, it can't get simpler than that. The correct one was C. And on your test, this one will be free response. So really know your stuff. Questions on this one? Others? 17. All right, so choose a correct simplification. What rule do I need to use for this one? There's 2 rules actually for this one. Quotient rule. So we know that when stuff is set up in this format, the variables of the same base, do we add, subtract them, multiply them? What do we do? Subtract them. And we'll get to the other rule when we get there. But we need to subtract them. So x to the 12th over x to the 2nd gives me x to the 10th. And then y cubed over y to the 15th gives me y to the -12. Now, are we allowed to have negative exponents in our answer? And if you look at your answer options, it doesn't have any negative exponents in the answer. That should have been your first clue. Like there's something else that we need to do. What's that rule called? The negative exponent rule. So if I have x to the -a, I kind of ran out of room, that's equal to 1 over x to the +a. All right, so anytime you have a negative exponent, save them for last. So we're at like the end of our problem. If it's not written in fraction form already, pretend like it is. Then take only the stuff with the negative exponent to move across the fraction bar. So do I need to move the x to the 10? No, just the y to the -12 will move over the fraction bar and be rewritten as positive. So when you clean this up, you get x to the 10 over y to the 12. So B. So 2 rules there. I made the key for the retake yesterday. I think you'll do fine on these, but you know, as long as you know like your quotient rule, your power rule, and the product rule, I think you'll be safe. Any others from the test? 2. So good one to go over because a good chunk of your retake is about like classifying by degree and terms. So look at it. if we're classifying by degree, go through all of your terms, because the degree won't necessarily always be on the first term for the overall thing. So degree means what, by the way? The exponents. So the formal definition is the sum of exponents on that term. So like if you look at the 5x squared, and we're only talking about the variables, what's my degree on the 5x squared? 2. What's my degree on the negative 8x? And what's the degree on the 2? 0. All right, so then your overall degree will be whichever of these is highest. So overall degree is whichever is highest. So then 2 is the highest, and it didn't say second degree, which honestly I'd be fine if you said second degree on your pre-response, but it used one of those fancy names that we learned, so you would have to look at your notes. What's it called when it's a second degree polynomial? I think it's quadratic, actually. No, not for degree. So for degrees, if it was a first degree, then it's linear, because that's like x to the first. Second is quadratic. Third is cubic. And fourth is quartic. So that sounds similar to quadratic, but not. All right, questions about that? Anyone get this one right? All right, so it is quadratic, right? Yeah. Okay. All right, and then the binomial, trinomial classifies by number of terms, by the way. So if you picked trinomial, yes, it is a trinomial, but that's not how you classify it by degree. That's how you classify it by number of terms. All right, good on this one? Any others? Number 5. All right, choose the correct classification. So first, they're not always going to be written in standard form. Is this one in standard form? So it's not in standard form. And standard form is part of your retake, so let's just take some time to talk about it. Standard form, what's most important? So that's the second most important. First most important is that they are in ABC order. If there's multiple of the same letter, like in this one, there's multiple x's, then you want the higher exponent first on that x. All right, so if I needed to rewrite this in standard form, which I know that's not what this question is asking, but it would be good practice for you, which one of these would go first? The negative 7x to the third, so keep the sign in front of each term. Next would be, and then, good, so any constants will go last. So this isn't in standard form, but this problem wants a correct classification. So first, by degree, what's the highest degree in here? 3. This one has a degree of 3, this term has a degree of 2, 1, then 0. So yes, third degree, and then they all said polynomial, but poly means how many terms? 4 or more terms. All right, so you have to see that it was a third degree. Questions on this one? On other ones? right? Don't be shy. If you want to see a couple more. Everyone get the f plus g of x right? Hold on, let's look at this one real quick, number 6. Do you guys know how to find the degrees when there's multiple letters in there? So like, what's the degree of this first term? 4, good. So add the exponents for each term. C to the 1 plus 3 is 4. Over here, what's the degree? Over here. So then the degree of this one is 6. So it's just whichever one's highest. All right, let's see. You guys know how to distribute, right? Okay, make sure you do that on your test. Same with this one. And to write in standard form. Don't write your answers in standard form, it's a -1. You guys know the product rule. What does the product rule say? Good, so x to the a times x to the b equals x to the a plus b. So we add the exponents when we're multiplying stuff with the same things. So that's why when we do the first term times this term, for the coefficients you treat like normal, 7 times 1 is 7, but the variables you use the product rule. So what's x cubed times x squared? What's 3 plus 2? Good. That's all you're doing here. What about y to the first times y to the first? Good. And then you move on. So like what would 7 times -3 be? So 7 times -3 is -21. X cubed times x to the first. And y times y cubed, y to the 4th. And then 7 times -4 is, there's no x here, so what do I do? So x cubed, you just rewrite it, and then I have y times y squared gives me 1. Okay? Any last minute ones you want to see? All right, I kind of checked your papers as when I was walking around earlier, so I believe you all did correctly. All right, don't lose your paper. We're taking the retake tomorrow, so I have faith in you. You guys did pretty good the first time.